My first bit I call Crazy Eights. That's the name of a card game. I don't know if you have it, Crazy Eights. I give it this name because we tend to think of counting by tens as rational, which makes counting by eights seem crazy by comparison. Now, in Understanding Media, Marshall McLuhan explored the idea that media are extensions of the human body. And he argued that numbers are an extension of the sense of touch. This is interesting. We can certainly see that base 10 mathematics are an extension of our fingers and toes. In fact, this seems to make counting by tens absolutely natural. You think about it, we can count with our fingers, we can count on our fingers, and we can count by using our fingers to point at objects in the environment. In all of these ways, we can see why the original meaning of the word digit is finger, and why digit later came to mean number as well. But digital does not mean decimal. And it was not till the rise of modern science and the Enlightenment that we created and adopted, in a broad sense, base 10 systems, such as the American monetary system of 100 cents to $1, and the use of floating point numbers, which is also known as scientific notation. But especially following the French Revolution, the metric system was introduced to increase the efficiency and ease of measurements and calculations. And today, the United States is considered irrational in its reluctance to adopt the metric system. Although I expect that digital technologies will soon speed the transition or maybe even render it irrelevant. But we might conclude that counting by eights is even unnatural as well as irrational. But we would be mistaken if we did that. And by way of explanation, let me tell you something about my own childhood. I grew up in New York City, and like many native New Yorkers, as a kid, I spent a good deal of time in pizza places. And we always ordered pizza by the slice. Inevitably, there are 8 slices to the pie. I spent many hours sitting at the counter of pizza parlors. Over and over again, I watched them take the pie out of the oven, cut it into 8 slices. But why 8? Well, simply put, 8 is the most rational, natural, and efficient way to divide a pizza. 1 cut, and you have 2 slices, 2 halves. Another, you have 4 quarters. Repeat the operation twice more, and you have your slices of 8. The same logic extends to coins such as the peso. Cut it in half, cut the half in half to make 2 quarters, cut once more, and you get your 2 bits. Pieces of 8 and slices of pizza both reflect the logic of cutting. And the same is true of the binary logic of digital communication. Each bit of information cuts possibilities in half. If there are 2 possibilities, such as determining whether a number is even or odd, it takes 1 bit of information to eliminate the uncertainty. If there are 4 possibilities, for example, determining the suit of a playing card, it would take 2 bits of information. One would determine whether the card is red or black, the other would determine which of the 2 suits it would be. If we have 32 possibilities, say, for example, the states of Mexico, it would take 5 bits of information to cut the choices down to a certainty, each time reducing possibilities by half. 16, 8, 4, 2, 1. It takes as many as 5 bits when you're dealing with the letters of the alphabet. If you include both upper and lowercase characters, that gives us over 50 possibilities, which requires 6 bits of information. Add the numerals 0 through 9, and add the punctuation marks, and we have something on the order of 80 different characters. At this point, we need 7 bits of information, and 7 bits gives us room to expand up until 128 possibilities. Now, 128 is the magic number of the American Standard Code for Information Interchange, otherwise known as ASCII. And that's the basic alphanumeric code of digital communications, especially in the English-speaking world. And it's for this reason that the byte became a standard unit of measurement. ASCII needs 7 bits, and the 8th bit was reserved for error checking to overcome noise in the system. So 8 bits, the byte, reflects alphanumeric codes. So in sum, 8s are not so crazy after all, at least not in coins and computers. This process of finding the rationale for human arrangements is sometimes known as cultural history. But I want to stress the intersection between cultural history and media ecology, which is the study of media environments. And that brings me to my second bit, which I've entitled "The Medium is the Message." And that, of course, is McLuhan's famous phrase. And in many ways, it's the basis of the media ecology perspective. Through "The Medium is the Message," McLuhan asks us to pay attention to the medium, to the forms and materials that we utilize, and to the means and the methods that we employ. For example, in the case of a pizza pie, given its form, its size and shape, and the use of a pizza cutter, it makes perfect sense to cut 4 times to yield 8 slices. Now, of course, it would be possible to cut the pie into 6 slices, or 10 slices for that matter. But the bias of the medium, the path of least resistance, brings us back to 8 time and time again. And the same is true when we cut silver coins into bits and pieces of 8. And by the same token, behind the binary logic of digital communication, there are technologies associated with electrical current and electromagnetic radiation. Electrical current has 2 basic states of on or off, and electromagnetic charge has the 2 basic states of positive and negative. Now, of course, electricity can be used analogically to reproduce sounds and image, for example, but the bias favors the digital. So whenever digital technologies are developed, for example, in sound recordings, in mobile telephones, now in video, the digital always replaces its analogical equivalent. Interestingly enough, the first form of electric communication, the telegraph, used an essentially digital code of dots and dashes. So the binary logic of electric technology can be used to represent any number of polar oppositions. For example, yes and no, true and false, up and down, black and white, and of course the numbers 0 and 1. But the point is that the true machine language of the computer is not the base 2 number system, but the song of the subatomic particle. Bits are electromagnetic units, and digital communication follows the bias of the electronic media. That's why McLuhan's analysis of electricity, of the electric age, is so appropriate for our current digital era.